From Microbe TV, this is TWiP, This Week in Parasitism, episode 130, recorded on March 28th, 2017. This episode is brought to you by Blue Apron. Blue Apron is the #1 fresh ingredient and recipe delivery service in the country. See what's on the menu this week and get your first 3 meals free with your first purchase with free shipping by going to blueapron.com/TWiP. Hi, everybody. I'm Vincent Racaniello, and joining me right here in New York City, Dickson Despommier and Daniel Griffin.
Hello, everybody.
Hello, everybody.
Daniel is in vivo. You're in vivo. Welcome.
You're in the flesh.
Nice to see you.
He's on site, in situ.
Periodically, you come and grace us with your presence.
Yeah, I was just seeing some patients this morning with the fellows, precepting the fellows over in clinic and then in the lab. And
Nice.
so,
And Daniel brought me a gift. Did he give you one of these?
Yes, he did.
Too?
Yeah.
It's a little box of Kava stress relief tea.
Yeah.
Non-GMO.
That's right, non-GM.
Thank you very much. I'll have to check it out because we've been talking about Kava for a while on TWiP. It's been an arc, right?
It's coming back up.
Well, this has got a bunch of herbs in it.
A bunch.
Kava root extract, and then it has carob pod, sarsaparilla root, cinnamon bark, ginger root, cardamom pod, and stevia leaf for a little sweetness, right? Stevia. I have a bottle of stevia liquid right there, concentrated.
Yeah.
I put a couple drops in my yogurt, and it is wonderful. It kind of got a vanilla taste to it, and it's just a little sweetening without any calories.
Oh, okay.
Very nice. How's everything, Daniel? Good?
Everything is very
The
good.
spring is here. You can start sailing again.
Yeah.
I'm ready. Definitely
Today would
ready.
not be the day to do it, though.
Not a nice
It got really nice. And then we had this snap of like cold and now rainy, and I'm ready for summer.
Well, the
I was,
point is... Sorry.
Yeah, go ahead.
I was just going to say there's a ton of fog out there right now.
Yeah, it's very foggy.
If you go out on the Sound, you're likely to end up in England.
I was at your old stomping grounds, or close by. I was in Denver last week for a visit for a day at the medical center. You know that new medical center they built outside of the city?
The old, was it the Fitzsimmons Air Force Base
It was
up
Air
in
Force
the north
Base.
or
Yeah.
something? Yeah.
It's in Aurora. And it was, actually it's called the Anschutz campus because a family donated a lot of money to help build it. And I landed on Thursday. It was 75 degrees.
Mm-hmm.
Friday morning, it was freezing. And then Saturday, it had gone back to warmer weather. So it's very variable there, the weather.
Yeah, no, that's the amazing thing is that you're at altitude, so the temperature is not held for very long. So clouds move in. You can go from 70 degrees to a snowstorm the same day. And
Right.
But
Plus a tornado.
I never got used to the altitude. You know, you go in and out, but I did feel a little headachy, you know, and a little fast pulse than usual because...
Well, we recommend that you don't drink alcohol while you're out there.
Exactly.
So next time.
I drank very little. I had only 4 total glasses of wine and a cocktail my whole time.
It's really, it's a question.
Within 2
it's a
hours.
question of how big the glasses were.
In a restaurant, they never give you big glasses, right? I had 2 glasses of wine on Thursday. They brought me out for a cocktail on Friday. You know, the campus is dry because the donors stipulated it had to be dry.
Oh,
So
interesting.
the bars all are cropping up at the very border of the campus.
Oh, wow. And there's also an issue, right, with NIH funding. It can't go to alcohol because people feel like we don't really want our tax dollars paying for scientists to drink.
Well, I don't know how they deal with it, but here they want you to separate the alcohol from the food, and I don't know how they reimburse those. But the people who took me out had to pay for the alcohol. The department couldn't pay for it.
Wow.
And they were all students, too. Too bad. I felt badly, so I didn't drink very much.
Okay.
Not that I ever do anyway. Daniel, remind us of our last case.
Excellent. As I like to say, for those tuning in for the first time and those tuning back in, do you tune? Do you tune a podcast?
Sure. iTunes, you know.
Yes.
You cursor in.
So for those of you clicking on the podcast, we presented a case of a young male in his 30s. This is a gentleman that I had seen. Initially came through the ER and then was admitted to the hospital. He was brought in by his male partner. This was a hospital, I said, in the New York area. he had a chief complaint of 1 month of significant diarrhea. The diarrhea was watery, non-bloody. He had abdominal cramping. He felt poorly, low energy, fever, some vomiting. He has lost a noticeable amount of weight. He feels like he just can't stay hydrated. His past medical history is significant for a diagnosis of AIDS, HIV positive, with a CD4 count less than 50. And he is not taking any medicines, no antiretrovirals. His viral load is elevated and uncontrolled. Family history, non-contributory. No other medicines at all, no herbal, etc. Social history. He had worked in an office prior to the diarrhea becoming so significant, but he can no longer work. He's living with his male partner, who's actually taking care of him. Occasional alcohol, but not quite that much lately with his declining health. No pets, no other significant exposures, no travel, just been in the New York area. His partner also is HIV positive, also not on therapy. When he's initially seen, he's febrile. He's got a temperature of 38.5 C, 115 is his heart rate. Blood pressure is 95/65. Respiration is 18. Thin male. He's clearly uncomfortable. He has oral thrush noted on the buccal mucosa. So we look inside the mouth on both sides. He has no subungual saliva. It's a very dry mouth. His lungs are clear. His abdomen is diffusely tender. He has increased bowel sounds. And we remarked that his labs, he had an elevated creatinine and BUN, decreased sodium, elevated WBC count, white blood cell count, with significant eosinophilia. But it is not over 9,000. I was waiting for you guys to chime in, but no. No pets, no houseplants, just sort of to throw that in.
And just a quick question, Daniel.
Yes.
Increased bowel sounds, that would be because of the diarrhea, things moving quickly in the bowel, is that right?
As your bowel becomes more active, you can actually listen, auscultate, and hear the increased sounds, gurgling.
What other conditions would lead to increased bowel sounds besides diarrhea?
Anything that's going to really irritate. So people might have they might have a colitis, they might have an irritable bowel.
Would a tumor do it?
So sometimes, if let's say there's a blockage or a narrow restriction, sometimes we hear high-pitched frequent bowel sounds, and this might be sort of a response to getting things past an obstruction.
It's like a Bernoulli effect, right?
Yeah. No, it's interesting. So not only will we get a change in frequency, but sometimes we get change in pitch and the type of sound. What we worry most about is an absence of bowel sounds. Right?
Really?
And that's when we have an acute abdomen where there's usually been a rupture or peritonitis. And when the bowel becomes inflamed in that context, it will actually stop. And you get basically a ceasing of the peristalsis.
You might be worried about C. difficile or things like that.
So when a C. difficile ruptures with a megacolon, you can get this. Sometimes when someone has a really severe, like blunt trauma to the abdomen, your belly will actually stop for a little while after surgery when the bowel's been handled. I had that issue, right? Remember I got in the belly with the cow in India, and for like a day or more, my bowel sounds just stopped because it was a hard enough trauma from...
You got kicked?
No, he like went with the horns.
Oh,
right into
you.
What do you call that when it doesn't penetrate, but you get like...
Well, you were
pseudo-gored.
It's not gored,
because I grabbed the horn as he was, so that prevented it from penetrating. But it was still a very if you were really hard butted in the belly by a sacred cow, you can have a absence of bowel sounds.
Good thing you grabbed the horn,
or anything that induces gas, right? I mean, you can have.
So that would be interesting. Like if let's say you changed your diet and had a lot of gas flatulence, you could have increased bowel sounds.
Sure.
Okay.
I think about that every time I think about Giardia, because it can give you all of these things.
Yeah, and the Giardia, you're having this increased fat because it's not being absorbed. Right. People with lactose intolerance can have increased bowel sounds, flatulence, discomfort.
Okay.
Another good point.
Just wanted to learn a little bit more about bowel sounds.
The flyer here is significant eosinophilia, in my view.
It's a flyer?
You have to think about all of the common organisms up to that point didn't induce eosinophilia. At least in my head, I was just trying to make my differential diagnosis. But when the significant eosinophilia popped up, it reminded me of something. So,
all right. Well, we have a number of guesses. The first is from Sue Ellen, who writes, time for me to take another semi-educated guess, this time on what's ailing the 30-something HIV patient who has presented complaining of diarrhea, vomiting, weight loss, and dehydration. This guy has a lot going on. So it was difficult for an amateur like me to separate what symptoms resulted from his parasitic infection and which ones from his untreated HIV infection. After some research, I'm ready to guess that our patient has cryptosporidium in his intestines, and those little guys are living it up and making his life hell. Crypto commonly causes vomiting, diarrhea, weight loss, and I even found some special recommendations on the CDC's website regarding the elevated risk of this parasite in HIV patients and others with compromised immune systems who are at higher risk for this parasitic infection. How did he acquire the parasite? That is much harder for me to say, but I did read that the infection can be passed sexually. So I would suggest that further examination include the man's partner. How did the partner acquire crypto? Can't say. Keep up the great work, doctors. Love the show. Love the cases. Sue Ellen in Roswell, Georgia. Isn't that where the aliens landed?
That's Roswell, New Mexico.
New Mexico. That was what I thought of when I see Roswell. I think of the Roswell.
That's right. The alien is inside this patient.
Dickson.
I know you had me read this one because of some reference, and we'll get to it. Wink writes, "Dear TWiP professors, I was a small boy in New York City in the 1950s, so one of my heroes was Mickey Mantle." And that's a great choice, by the way. "I am proud to have approximated Mantle's batting average for my TWiP diagnoses."
What would that be? 300?
About 350, 360.
Oh, really? That's pretty good.
Then that's good for a batting average, but maybe not so great for a diagnosis. Yeah, that means you've got more than half wrong. My swing at the man with AIDS, wasting, and eosinophilia is cystoisospora, previously known as isospora. My diagnostic test of choice is to send a stool sample to Dickson.
Why is that, Dickson?
I'd be happy to receive it.
What would you do with it? Would you look at it?
Oh, the possibilities are endless.
Okay. Daniel.
Yosef writes, "Dear TWiP team, for my differential, I'm finding it difficult as I can't narrow down my differential to a single diagnosis. So here are my thoughts. Unlikely diagnoses: Cyclospora cayetanensis, Cryptosporidium parvum, and Giardia lamblia. None of these present with a significant eosinophilia as far as I can tell, and I don't see any risk factors that could lead to them, such as consumption of raspberries or contaminated water. However, I am assuming that this infectious agent was either brought in by the patient's partner or acquired from the nearby area. More likely diagnosis: Cystoisospora, Trichiuria." I need your pronunciation guide with me right here.
We've been working on Daniel.
Strongyloides. I'm going to bring it next time. Capillaria philippinensis, Hymenalepsis nana, Paragonimus westermani.
Wow.
Cystoisospora, one of the few protozoans that can lead to eosinophilia, and so is on my list. It is transmitted by fecal contaminated food or water. Trichuria, not too high on my list due to the patient not exhibiting many of the classic symptoms like tenesmus. I can't rule it out completely, though. Strongyloides. I was hoping for some type of rash or cough to help identify this one. Furthermore, I'd be worried about dissemination in someone as immunocompromised as our patient. Capillaria philippinensis. Unlikely because our patient is not in the Philippines. Hymenalepsis nana. Popularized because of the Colombian patient with the nests of neoplastic cells that were thought to have been driven by this infection. Our patient is not in the Mediterranean, so this is again unlikely. Paragonimus westermani, obtained from cray and crabs, neither of which were mentioned in the case. Furthermore, I would expect some type of pulmonary complication. Overall, I don't have enough information to say that any of these are definitive. For our patient, the first thing I would want to do is start some form of IV fluids. He seems to be extremely dehydrated, and treating an infection is pointless if he dies before it can be cleared. I would then want to order a stool over in parasites to see if I could get any information on which parasite is likely and to what medication may be started. Despite all the parasites listed above, I would still not want to rule out a concurrent viral or bacterial infection. I don't think I would wait for the results before starting antibiotics and anti-parasite medication. I think I would start off with albendazole, ivermectin, TMP sulfa, and azithromycin for MAI. If none of these work, then I would be worried about a fungal disease, maybe GI candidiasis. Please let me know if my reasoning is flawed. So let's go back to his later. Yeah. We'll sort of pull some, because there's some interesting comments there that we'll want to make.
You bet.
And he also has a PS and a PPS. So PS, I guess that's postscript. When discussing Onchocerca volvulus in the last episode, I remembered that there was a paper that you guys discussed about using imatinib to treat filarial ABL-like kinases, and this could treat the adult filarial worms and thus bypass the 20-year ivermectin treatment. Do you think there's any chance that this could one day be a possibility, or is imatinib just way too profitable expensive for this to be done? PPS, and that would be postscript, I believe.
Yeah.
This case reminds me of a play we recently performed at our school called A Question of Mercy by David Rabb. I don't know if I am allowed to attach the play because it is supposed to be distributed solely for educational purposes. But if you want to see our performance, it is here, and he puts a link here to the School of Medicine presentation.
Oh, nice.
This play is about a terminally ill AIDS patient in New York City during 1990, suffering terribly, also from diarrhea, and his wish to end his life.
Educational purposes, isn't that what we are?
I think so.
Yeah.
Yeah, we're not really making any money here, are we?
But the link is not.
Are you guys making money and I just don't know about it?
The link is.
I am. I don't know about it.
The link is good enough. It's a YouTube link, so people can watch it.
Sure.
So we'll go back and talk about a lot of his things.
Yep.
Okay.
Including I watched that presentation. It's like an hour long. It's quite a long thing.
Wow.
Peter writes, "Greetings, TWiP team. I am currently in Mersin, Turkey, where at the time of writing it is dry and sunny with a temperature 22 Celsius. The patient in this case study has untreated HIV/AIDS, so will be susceptible to numerous opportunistic infections and possible reactivation of latent infections. The described gastrointestinal symptoms of diarrhea, vomiting, abdominal pain, weight loss, and dehydration were common in AIDS patients before the widespread use of HAART. I think that the symptoms indicate a protozoan parasitic infection of the intestines rather than a helminth, though I suppose co-infection is a possibility. I presume you'd want to start the patient on HAART before continuing with the diagnostic testing. Having done a literature search for opportunistic parasitic infections in HIV/AIDS patients and listened again to some early episodes of TWiV, I will stick with protozoan parasites. Most likely include Cytoazospora belli, Giardia lamblia, Cryptosporidium parvum, amoeba, and Microsporidia. Given the lack of pet ownership, zoonotic infections are less likely. A lack of foreign travel limits the parasites. I would make a guess at this being a food or water-transmitted parasite. Further analysis of stool samples, colonoscopy, and biopsy will be required to clearly identify the parasite. I strongly suspect that the patient is suffering from cryptosporidiosis due to Cryptosporidium parvum infection." And then he gives a quote from the CDC about treating it with nitazoxanide.
Is that going to be in your pronunciation guide? You're going to help us pronounce
You want
the
drugs also? Okay, I can work on that, but I'm not as familiar as I am with the organisms' names.
Okay.
Without antiretroviral treatment, cryptosporidiosis has a high mortality rate for AIDS patients, and even with antiretroviral treatment, total elimination of the infection is unlikely. Regards, Peter.
Right.
Dickson.
Michelle writes, "Dear TWiP team, for the case of the HIV-positive man with chronic diarrhea and eosinophilia, if the diarrhea is of infectious origin, it appears that it is due to an opportunistic pathogen which the man is susceptible to due to HIV infection. Although I don't recall any CD4 cell counts given, I'm presuming that they are low because the man is not on therapy, has oral thrush, and his partner, who is HIV positive, remains unaffected. The more common opportunistic pathogens in the HIV/AIDS patient population in the U.S. that cause diarrhea include Cryptosporidium parvum, Cyclospora species, Cystoisospora species, Microsporidia, Blastocystis hominis, disseminated MAC, and cytomegalovirus. There are many other viruses and bacteria that could be involved. The HIV virus itself can also cause enteropathy, and there are possible non-infectious origins like inflammatory bowel disease, but I am guessing that there's a parasite involved. The clue of eosinophilia suggests cystoisospora belli. In parasitic diseases, cystoisospora belli. Dientamoeba Fragilis are sarcocystis species which can all cause diarrhea in AIDS patients. The patient's symptoms are textbook for C. belli, which is an apicomplexan parasite that infects the intestinal epithelial cells. A person becomes infected by ingesting oocysts, typically through ingestion of fecally contaminated water or food. Symptoms in the immunocompromised population include chronic diarrhea that can be extreme, weight loss, weakness, and fever, just as described for this patient. The diagnosis is to find the oocysts in stool and are acid-fast staining. Treatment, a long course of trimethoprim sulfamethoxazole. Dientamoeba fragilis is an intestinal amoeba that is obtained through ingesting cysts that are passed out in human feces. This pathogen can be diagnosed in stained fecal smears, fecal cultures, and PCR diagnostics. Sarcocystitis is not strongly associated with HIV patients, and thus it is down further on my list. It is another apicomplexan that is obtained by eating undercooked meat. Its life cycle involves an intermediate host. Oocysts are passed in feces of the definitive host and ingested by an intermediate host, often cow or pig. The sporozoites invade tissues, undergoing several rounds of reproduction, ending their final round in the muscles. Thus, eating the undercooked muscles transmits the parasite to the definitive host. Thanks for the edutainment, Michelle.
Daniel.
Carl writes, Dear TWiPniks, you mentioned that the ill man in TWiP 129 had a diagnosis that was in Parasitic Diseases 6th edition. I figured that meant I had a chance of figuring it out despite my complete lack of medical and biological training. So last night I decided to lull myself to sleep by reading all the paragraphs in your book containing the word diarrhea.
My goodness, that would put you to sleep.
Fascinating as this was, it was also time-consuming, and I nodded off between the section on protozoa and the section on nematodes.
Right.
But I think I found a good protozoan diagnosis, so I feel confident in saying that this is a case of Cytoisospora belli, or it's some worm from the 400 pages of the book I didn't read, in which case you can all have a good laugh. This is one of the 3 protozoa that cause eosinophilia. And of those, one of the 2 that causes diarrhea. And of those, the only one found in New York. The only one prominent in immunocompromised patients, and the only one where the diarrhea is bloodless. Googling around, it seems like the usual treatment for this would involve, in addition to the anti-protozoal, starting antiretroviral therapy so the patient's immune system can clean up the mess. I wonder how this will affect the patient's decision to forsake such drugs. I'll look forward to finding out in your next thrilling episode. It is a gloomy 40 degrees Fahrenheit here in Lexington, Massachusetts, as the rain erodes the last piles of winter's snow. Carl F.
Thrilling. Do you think he's saying that sarcastically?
Hopefully not.
Hopefully not. Gavin writes, Dear TWiP team, I'm running way behind on my podcast, so I need to submit my guests for TWiP 129 ASAP. Could you give us some guidelines on when we should have our guesses in? I work so much better when I have a deadline. Well, we do 2 a month, so when one is released, the next one is not going to be released in the next week, but the week after that, right?
But then there's a little gap before it gets... You post pretty quickly now, but you have about 10 days from the release.
Yeah, usually about 10 days.
Yeah.
So we're recording now on a Tuesday. I'm not going to post this till Saturday, though.
Uh-huh.
And then probably in 2 weeks, we'll have our next episode. Yeah. So that's a thumbnail. So just think 2 per month, and we try and space them out.
So listen to this. Put everything else aside. Soon as this comes out, listen.
Yeah, you have about 2 weeks. You'll have,
and then you can relax and do all
maybe
that
a week
stuff.
and a half after this comes out. That's
Right.
rough. That's roughly it. Right. All right. There are a lot of great review articles on diarrheal diseases in HIV-infected patients. It seems that CMV, cytomegalovirus, cryptosporidium, E. histolytica, etc., are all on the list of usual suspects. However, I'm beginning to suspect that we evolved eosinophils to aid in our differential diagnosis. Cytoisospora belli, Dientamoeba fragilis, and sarcocystis are among the few pathogens which cause diarrhea, and eosinophilia. Sarcocystis seems to be uncommon in the U.S., and our patient does not report eating undercooked meat or travel to Asia. D. fragilis is an interesting possibility, but my guess is Cytoisospora belli. As is often the case on TWiP, the proof is in the pudding. Cytoisosporosis can be detected in the stool via autofluorescence. Treatment is with trimethoprim and sulfamethoxazole 2 to 4 times a day, 10 to 14 days. The patient should be started on heart with caution given to iris. I wouldn't be surprised if there were a co-infection as well. Thanks again for such a wonderful podcast. I appreciated Dr. Griffin's medical school advice. I'll keep you posted on where I end up after April 30th.
Oh, that's exciting.
Is it cytoisospora or cystoisospora? The way you pronounce it. Cysto or cyto? Because some people are writing cyto and some are
it's
writing...
actually, there is an S in there. So it's actually cystoisospora.
Yeah, so this Gavin here. Gavin,
but I have to admit, I'm guilty of this myself. I often, when I'm not, I will often, I pronounce everything wrong. I think we established that? I have often called it cytoisospora.
Isospora, right?
C. belli would be much better.
No. Dickson Despommier. Cystoisospora, right? The accent is like that, not cystoisospora.
No, cystoisospora.
Got it. Cystoisospora. Say that 10 times fast.
Yes. And it was renamed. Right. So when Dickson was teaching me back in the dark ages, this is like back in the 80s or something. That's the
1980s, by the way.
It was isospora.
Mm-hmm.
Then it was renamed.
That's right.
And so now they've added extra and confused everybody.
We had a couple of cryptosporidium and a couple of cystoisospora. Belli.
Right. Belli.
Come belli. Come sono belli.
Exactly.
Come bello or bella, whatever the gender is. Okay, so Daniel, what happened in this case?
Well, we usually let you guys tell everybody what you think. So we'll start with you, Vincent. What do you think? Are you going with the eosinophilia?
Yeah,
is that
because
going to drive you?
That one, who was it that put it perfectly? Eosinophilia helps us on our differential. Eosinophilia, bloodless, diarrhea. I think cystoisospora is a good candidate.
Okay.
And I thought that the moment you mentioned it last time, I did a little Googling and
That's right.
I thought that would be it. And I heard
having just fresh off read the entire book. By the way, without going to sleep, I must add.
You read the whole book?
Yeah, of course.
Is it good?
We wrote the whole book.
Is it a cliffhanger?
It's a page turner, as they would say.
Someone should write a book and have the author, the nom de plume, Paige Turner.
Ted Turner's brother, Paige.
Yes.
That's right. Okay. So I echo your sentiments exactly, except that why should we have to guess? Let's look at the lab results.
So I do, we always like to think it through because the lab is hopefully going to confirm our diagnosis rather than give it to us. But as we've talked about now with modern technologies where they just say, send it off for the GI plex, you get the answer. You say, diarrhea, order the GI plex. So in this case, we had significant eosinophilia. And I agree. I mean, the eosinophil level can help me in my diagnosis. And a really important thing when dealing with an HIV patient and actually dealing with eosinophils in general is you want to know the absolute eosinophil count, not the percentage. Yeah. And the reason that's the case is often with HIV, because it's going to affect the lymphocyte lineage, your percent of eosinophils can be higher than would be expected, but the absolute number is not elevated. So it was important. I said here that he had significant eosinophilia. So I didn't want to confuse anyone who would say, well, you said high percent eosinophils. Yeah. What does that really mean? You want to then always look at the absolute count. So the absolute count in this case was well over 500, well over 1,000. It was a truly elevated eosinophil count, not above 9,000. But so it was true eosinophilia. So that's important because only certain causes of diarrhea will give us that. And so we think of what causes eosinophilia. We've been through this, right? The China mnemonic, the NWACP mnemonic.
Yeah.
And that really narrows it. That helps us with our differential. And then the fact that we're talking about an HIV positive person with AIDS, with C4 count below 50. So that narrows us further. And this is critical. Let's say you followed the advice of Yosef, right? We like Joseph. He gives us lots of good advice.
He does.
And you say, oh, why don't you send an O&P on this patient?
Mm-hmm.
Okay? And in this patient, he had an O&P sent. It was negative.
Exactly.
Why was it negative? Because you need to request a special O&P on an HIV patient. You need to request that they do an acid-fast staining on the O&P. I think someone said the proof is in the pudding, and I think by pudding they meant feces.
Right, that's right.
So
they said
Proof is in the poo.
So you have to request a special acid-fast staining.
It's a cold acid-fast
Yeah,
stain.
It's a cold
Michelle
acid-fast.
Michelle said that.
So that's critical.
Yeah.
So you actually really need to be thinking. You can't just say, "Oh, I'm thinking."
Except that cystoisospora autofluoresces, so you could look at it under a fluorescent microscope without staining and still see it.
And they are big, right? They're fairly big.
huge.
They're huge. So
Absolutely huge.
So in this case, this was done, with that thought in mind,
Right.
and the AFB was consistent. We actually saw these elongated oocysts.
The unsporulated oocysts.
Yes, exactly.
So I would like to add a little hint as to what to do when you do hear eosinophilia in a differential diagnosis. It raises a red flag. I always think of it as a red flag.
Red, because eosinophilic
So eosinophilia is red, so it raises a red flag. You should always, is it an allergic response? Is it a reaction to a drug, or is it an infectious agent? Those things. That's all. Or remotely, is it eosinophilic leukemia, which is your last guess ever, because that's one of the most rarest forms of leukemia you can imagine.
Yeah.
Do viruses cause eosinophilia?
Great question.
That's one we should look at you for.
Yeah, I'm not the doc. You
Was
are.
that a rhetorical question?
No, and actually, so sometimes we'll see. I was actually just talking to Steve Goff earlier about a really interesting case. It was a returning traveler that I saw, and she came from India. And when we're putting it all together, it looks like a very interesting manifestation of an HSV1 infection, right? Mm-hmm. And so she had massive lymph nodes in her neck and her spleen, like not normal what you think. And as the disease progressed, it involved her skin. When she got skin involvement, later in the course, we saw eosinophilia. And I think we see it because now you're sort of getting this immune dysregulation. You're getting an almost an allergic type response as the disease is progressing. Right. But what I wanted, and I tried to make a point, I always pick the cases to be good ones to help with. And this was a person who was on no medications, taking nothing that would be a first world precipitant of eosinophilia, of eosinophil expansion. Because you might see someone come in with diarrhea and they've got increased eosinophils, but it's because they're taking something. And sometimes the diarrhea will be because not only are they having an allergic response that might involve their skin, there might be a rash, they may even have significant irritation of the GI mucosal surfaces, and they're getting a watery, profuse diarrhea.
Right.
This is the wrong patient for all that.
Yeah.
Maybe. But a lot of times people in the HI community, I think more in the past, were really disillusioned by the medical profession, and we're seeking a lot of alternative therapies. And so you would see hepatotoxicity, you would see allergic reactions because of all the many things they might be trying to take.
Wow. Okay. Now, how did you treat this gentleman?
So the first thing, and I know that Dickson brought this up last time, is he's not on his antiretrovirals. And so there was a whole discussion there, and he was willing to try again with antiretrovirals.
So he had been on them, but he didn't stay.
No. So he had not been on them. He didn't want to be on them. He didn't believe in them or was concerned.
I see.
So he did agree to start antiretrovirals. We also put him on trimethoprim sulfa, and it was a prolonged period of time before we saw the diarrhea improving. So
How
very
about his
slow.
partner? Did you have a discussion with his partner about going back on retro?
So interesting. It was actually my colleague was who I was working with in the hospital, was the outpatient doctor who took care of both him and his partner. So he was involved in this because it's really a challenge. You don't want to be like the hospital doctor who says you got to take your medicines. You want to have that relationship. And, in a perfect world, the outpatient doctors could actually come and talk to them and help with making that relationship and commitment.
So what did happen there?
At least when he left the hospital, he was on his antiretrovirals.
Yeah.
The partner was going to discuss with my colleague starting antiretrovirals himself. So,
Would you suspect that his CD4 count will rebound?
To some degree, yes. Depending upon how long it's been low, that can impact how high it can potentially rebound.
Okay.
If someone comes in acutely ill with a low CD4 count, we can often get that back into the normal range. We meaning the patient and us working together. If it's been down for a very long time, the rebound often can't get above 200. So that's one of the big reasons for really wanting to go ahead and treat as soon as possible. Okay. One of the many reasons now.
So where did he acquire this infection?
Well, we talk about fecal oral, so just in the environment, it probably somehow got into his water or his food.
New York City is a plethora of opportunities for pathogens.
So a healthy person would also encounter this, but never get infected.
Or me get infected, but wouldn't suffer like
probably
this.
Wouldn't suffer. It would probably clear it themselves. You'd never know about it.
Okay.
Exactly. Maybe small children might get sick. Older people like myself might get sick.
Dickson, yesterday in my virology class,
how'd that go?
We were talking about fecal oral contamination routes, and I gave them the quote that you told me years ago from the fellow at Rockefeller. The whole world is covered with a thin layer of feces. Of course, he didn't use the word feces.
No, he didn't.
That was Bob Shope.
Senior.
Did he really have that over his door?
Yes, he did. Yes, he did, as a quote in big, bold letters.
My class, they giggled when I said that. Yeah.
At that point, he was looking at the transfer of viral infections via parasite eggs.
Yeah, I remember that, which is not really a good thing. But, yeah, we do have a lot of fecal contaminated everything. Yeah.
So we live at a sea, right? We live at a sea of microbes.
We do.
People are also not good about their hand hygiene, right? All right, and
actually, that's a huge thing. People are not good about hand hygiene. We'll reinforce that. Not only do people, it seems silly. Not only do people not wash their hands often enough, but very few people wash their hands properly.
Yes,
it takes time. Things take time.
Don't you have to recite the alphabet?
You should have a song. You should be singing a song of some sort, or have some.
What song do you sing?
Just to. Well, you see, you could do the Happy Birthday song. That's one recommendation. That's Twinkle, Twinkle, Little Star, which I still can't get the words right. The alphabet, which occasionally I get caught up somewhere midway through. Well, I always thought like LMNOP was like a word, but apparently it's LMNOP. And if you do lump them together, you can get through a little too quickly.
It can.
It's 26 separate letters.
It's all true.
But it takes time. And there's certain parts people always miss. The left hand, the part basically proximal to the thumb. There's like a whole area that basically is filthy on most people. And if you watch when they clean, they somehow spare that part.
I'll be darned.
So what they do, it's interesting. They have these fluorescent powders that they put you put them in your hands and you say go wash. Everyone washes, and then they come out and you're like, their hands are still filthy. Go watch it. And these are people like in their 20s and 30s, and you're like, really? You have yet to learn how to wash your hands properly.
If you're in an airport, you watch people. They're just doing the palms together. Now, my dad was a surgeon, and even at home he would do the amazing putting the hands.
So you got to roll up your sleeves. You got to do it. Yeah, because people are worried, because their dress shirt's going to get, the edge is going to get a little wet. So they're just doing a tiny little, just so in case someone sees me, I can check that box. But no.
So I wonder if Semmelweis had a set of printed instructions.
Yeah, I don't know.
To give lessons to somebody, teach them how to wash their hands, they almost feel like you're being condescending. Come on, I know how to wash my hands. Don't be silly.
Well,
of course we don't.
One of my colleagues and I were talking the other day in the hospital about they now have these alcohol dispensers everywhere.
Yeah,
and the idea is you'll watch
Purell or something.
Yeah, and what we were talking about is what they should have is a dedicated one per patient. And when you cross the thresholds, it actually has the ability to note whether or not you have then hit the Purell. So think about it you get in the car or whatever and something's activated if you don't turn the key or something. So you you cross the threshold, you've now entered to interact with the patient. If you don't push that button and activate, it's a turn off the sensor and start doing your hands, it alerts you, like a seatbelt. Please wash your hands. Please wash your hands until you reach over and do it. And it probably would be cost effective.
I just had this interesting thought as you were talking of going into a men's room, let's say at an airport, and you see all the sinks are lined up, no more faucets. You stick your hands underneath there, you don't touch anything. You get the soap dispense the same way now. You can lather up, once you've rinsed, you've got these Dyson blades that you put your hands through to dry them off, so you don't have to touch anything.
You remember on TWiP, the ship's agent from Norway who told us about that?
Yeah, well.
So this guy takes care of cruise ships. He said they're starting to install these sinks. There are 2 holes in the surface. You put your hand in.
Oh, yes.
They wash it with soap and water, and then they dry it all at once.
They wash your hand.
Yeah.
So
Over at North Shore Hospital, they have one of those on one of the floors, and it's the weirdest thing, right? You do have to pull up your sleeves, right? Because you're going to put your arms into this like mysterious chambers,
and it takes
a period of time. And yes, it wets your hands, it soaps them up, it scrubs them, and then dries them, and out come your clean hands.
Oh, funny. And then you wipe your nose and go off into your...
Yes.
Well, this same ship's agent had a few years before told us that they had thousands and thousands of Purell dispensers on their ships, and we pointed out to them that this does not inactivate norovirus, which is the main reason they're doing this, because 70% ethanol, polio, also any of these icosahedral viruses are very resistant, and so washing with soap is the way to go. This reminds me of a period in New York City where the city was installing restrooms, public restrooms, stainless steel. You'd go, and when you closed the door, the entire interior would be washed and dried automatically. So the next person would have a very clean interior.
Yeah, I remember this.
But they never, I don't know, maybe they were too expensive.
There's an odd legacy law in New York City where somebody at a period of time said, we really shouldn't charge people for toilets. So it was a law passed in New York that you can't charge for toilets, thinking like this will prevent people from charging for toilets. But what it prevented was potential installations where you could charge 25 cents or some small amount that would cover the cost of the installation. So New York City has an incredibly low public toilet to person ratio.
They do.
It's a problem.
They never see any.
They've solved that in Paris.
How's that?
They have
it's called the alley.
They're outdoor pissoirs. No. They have outdoor places that you can actually urinate. Defecation is more difficult.
What were some of these things we wanted to go back to here?
Let's go back. Let's make sure we don't neglect anyone.
So there was one question about imatinib and treating filarial diseases with it.
We did. So we had the
that was Yosef. He wanted to know if this is going to happen.
Okay, so let's go through Yosef's comments. Yeah. So I like his differential. The one comment I would say is, a couple comments I'll throw in. One is that if you're going to do the O&P, Yosef, make sure you do the acid fast. And he's actually out at North Shore where he could put his hands in that special cleansing.
He could do
Yosef, go see if that's still, it was like at the 5th or 6th floor of Monty or something. So go wash your hands and tell us about the experience.
Yeah.
The other thing I will say, so he brought up imatinib. So that's a great one to bring up. So imatinib in the United States costs something, $80,000 a year? It's very expensive. It's patent protected. It was a very famous court case in India where in India they
Gleevec is the other name.
Gleevec. Yeah. They used to have a situation where they didn't respect patents in India. And they, basically if a medicine can be made, it can be made. It's all good. And it was really the makers of Gleevec that pressured the Indian government to do something, to have some sort of respect for patents. And the range of cost currently of Gleevec could be as low as maybe I think $1,200 a year in India versus $90,000 here. So there's two aspects. One is patent protection. How much are people charging for various reasons, and sometimes even the generics are not cheap. And the second is the production cost. So once you get away from all the patents, how much can you produce that? So ultimately, whether or not Gleevec can be used in these different contexts, I think ultimately as we get past patent protections is going to be what's the cost? Like how inexpensively can you produce these drugs? So who knows, in the future, will there be a way to show that it's cost effective or it'll become there'll be a cost break point where it can really be utilized. And instead of this one drug, just think of the logistics and costs of 20 years of yearly treatment versus a curative treatment.
Oh, that's true.
All right.
What else was the issue? What other things did we see in his? Let's cruise forward.
We had a few guesses for
there was a mention of colonoscopy and biopsy. Usually you can detect this in the stool, but occasionally you can't. but yet you still really feel strongly. And sometimes you have to do an upper endoscopy and a duodenal biopsy.
Wow. And
these will actually be found intracellular. So intracellular phase. Let's see what else we got here. Dientamoeba fragilis, right?
Yeah, very rare to be causing that much disease because it took a long time just to rule it in as a pathogen because of its epidemiology. It's so fleeting and I would say ephemeral. By the time you look for an outbreak, I've never heard of any outbreaks of Dientamoeba. It's single cases or families or things of this sort, but it's not large groups like you would have, let's say, at an institution for amoebiasis due to E. histolytica, for instance, which happens a lot, or at least it used to. Dientamoeba fragilis has remained on the edge of, does it cause disease? Doesn't it cause disease? It's like blastocystis almost. Now it's moved into the realm of mild pathogen, but it wouldn't result in a diarrhea of this severity.
That's probably the thing. Is, I mean, we did discuss those cases in Australia, and I think it's important to keep in your differential of things that cause diarrhea and eosinophilia.
Right.
But yeah, I think all those points are well taken.
I like the reference to apicomplexan.
Yes.
That sort of rules in the group of organisms that all contain these rope trees and micronemes, which gain entrance into cells or alter their physiology, at least in some way, to aid the parasite carrying out its life cycle. It's good to keep in mind the groups of parasites that fall into these categories. So I like that.
And then hopefully, good luck, Gavin, on getting into medical school.
Yeah, and my hope is also the guy who fell asleep eating all the diarrheal disease-causing agents didn't fall asleep the moment he got to Trypanosoma brucei rhodesiense.
But he got the right organism, Dickson.
Which causes sleeping sickness, by the way.
He got the
right organism. He did get the right organism. That's true.
Fine.
Oh, and then the Philippinensis, not just in the Philippines, right? It's also in Thailand, other parts of South Asia. So
that's right.
Not just the epidemiology. And, and I guess I was surprised and happy. I was, when we were giving advice about medical school and getting involved in research and we were recommending different meetings, I was sort of hoping to annoy enough that I would get a response on saying that you should go to the ASTMH and not the ASP meeting.
Go to both.
And no one responded back. I was like, it's much more vibrant. I was sort of waiting. Isn't somebody going to come back and go, ASP is great too?
Maybe you still time.
There's a different take on the same organism from these two organizations. Yeah. So that very often they met together, and that was kind of an interesting meeting to go to.
Right. Okay. That'll do it.
Right.
Well,
now.
This episode is brought to you by Blue Apron. Blue Apron's mission is to make incredible home cooking accessible to everyone while supporting a more sustainable food system, setting the highest standards for ingredients, and building a community of home chefs. I just learned that Blue Apron is building a warehouse in Linden, New Jersey.
No kidding.
Which is not too far from my home. Linden is famous for what, Dickson?
Linden, let me think. No, don't tell me. I don't know.
Well, it has a large Polish community, so they have wonderful pierogies.
Did not know that.
And lots of Polish stores. But they have the Exxon refinery there. It's what gives New Jersey a bad name.
It's the first thing you see if you fly into Newark.
Huge tanks and cracking stations, distilling the oil and so forth. So Blue Apron, they have
soon to become an outdated paradigm.
Yeah, with electric cars.
Well, I think we're moving in that direction.
I don't know how
rapidly.
soon is. Maybe it's going to be a while.
10 to 15, 20 years from now, maybe.
Yeah.
No, Las Vegas just went off the carbon grid.
Okay.
That's a whole city.
Yep. Well, so Blue Apron has warehouses throughout the country where all the food comes and they put it into the boxes and they ship it to you.
Right.
What they do is they ship you seasonal recipes with fresh, high-quality ingredients so you can make home-cooked meals. You get all the ingredients you need except salt, pepper, and oil. Then you get step-by-step recipe card, a lovely card that you can keep and reuse over and over again. Pre-portioned ingredients, 40 minutes or less, a great meal, less than $10 a person. How do they make it so cheap? Well, they have over 150 local farms, fisheries, and ranchers across the U.S. that they contract with, and they do so responsibly. Seafood is sourced sustainably under regulations developed with the Monterey Bay Aquarium Seafood Watch, beef, chicken, and pork from responsibly raised animals, produce from farms that practice regenerative farming, and they ship exactly what you need, so there's no waste and you don't overeat. You can customize your recipes whenever you want them delivered. Meat, non-meat, whatever you want. They have a lot of different choices. You can order for 2 people or 4, and they deliver to 99% of the continental U.S., and every month they have brand new recipes. So for April, here's what they have. Spinach and fresh mozzarella pizza with olives, bell peppers, and ricotta salata. That's the dry ricotta that you can actually grate.
Okay.
As opposed to the mushy stuff that comes in the plastic buckets. Sweet and sour salmon with bok choy, carrot, and ginger fried rice. And baby broccoli and fontina paninis with hard-boiled egg and arugula salad. Wow. They don't repeat their recipes in the year, so you're never going to get bored. Check out this week's menu. Get 3 meals free with your first purchase with free shipping. Go to blueapron.com/TWiP. Make sure you do that, the TWiP part. blueapron.com/TWiP. You'll love how good it feels and tastes to create incredible home-cooked meals with Blue Apron, so don't wait. Blue Apron, a better way to cook. You know, you can save the recipes and make them on your own if you'd like. You've done this, right, Daniel?
I am a regular Blue Apron subscriber. And you know what's nice? I don't think you brought this up, that with the length of our episodes, you can listen to the TWiP while you're making your Blue Apron food.
Do you know what people can do? They can, those computers now, the Amazon has that thing you can talk to, and Google has one, Yeah.
Alexa is what?
Yeah, something like that. Alexa. And you could say, Alexa, well, you're not supposed to say this on podcasts because it activates everyone's thing.
Really?
No.
You could say, hey, lady in the tube, play TWiP 140, and then you can go cook, and it'll play right in the tube because it's a speaker.
Oh, that's really
Isn't that cool?
I like
you can have it sitting in your kitchen. And so there are some very popular podcasts with hundreds of thousands of listeners, and they often get emails from Amazon when they say that, because they say, you just triggered everyone's lady in the tube. So say lady in the tube because it's a little tubey type thing.
You don't want to actually call her by her name, or it will suddenly start playing from the beginning of our episode
Amazon
again.
Lady, we could all trigger TWiP 130. What are we on? 130.
130.
We could just do it, but
yeah.
Can't trigger it while it's playing. You see, so we're going to have to do something else.
That's great.
Anyway,
insert a little in a RNAi. It'll work.
I now see the boxes all over the streets being delivered. The Blue Apron is a blue box, nice. Being delivered. Very cool.
Very nice.
We do thank them for their support. TWiP. All right, we have a paper from PLOS Pathogens.
We do.
It is an article entitled Exosome Secretion Affects Social Motility in Trypanosoma brucei, and the authors are from the Bar-Ilan University in Israel. First author is Dror Eliaz, and the last author is Shulamit Mikhaeli. And Trypanosoma brucei, Dickson, is a cause of what?
Well, that's the parent organism, but then there's rhodesians and gambians. They both cause African sleeping sickness in humans. But Trypanosoma brucei causes trypanosomiasis in animals.
Oh, really? Does it make them sleep?
No. The African animals,
they're
quite tolerant to the whole thing.
They don't get sick at all, do they?
They don't get sick. Yeah. That's interesting.
And how does this... So brucei doesn't go into people?
Not without that little... subspecies addendum.
Got it. But what would bring it from an animal into another person?
A tsetse fly.
Now, does it go from person to person at all?
Not directly.
Animal person.
It needs a tsetse fly.
Okay, so like West Nile, birds, human, birds, human, birds, human, right, by a mosquito, right?
Yes, that's exactly right.
A biting mosquito.
In fact, the name brucei refers to Bruce, who discovered this parasite.
The DJ, Cousin Brucey?
No, this is another Bruce.
Remember him?
I do.
He was a New York City disc jockey.
Okay. I don't.
He's still around, I think.
I don't think I ever knew to forget this.
So his first foray into science was, I think, in Cyprus, where he was looking at the cause of spontaneous abortion in cattle. and discovered the Brucella abortus, which was named after him, and then moved to Africa to look for more infectious disease agents and discovered Trypanosoma brucei, which later 2 other people, actually 3 or 4 other people, described these other 2 varieties in people rather than in animals. But these parasites together as a group limit where people can live because it limits where their cattle can live.
Yeah.
And that's the idea here.
Now, to
find out what's going on.
One of the points of this paper is that the parasites migrate within the insect host.
They do.
Tell us about that.
They do. Well, part of the life cycle involves that the trypanosomes are taken up by the tsetse flies, and they differentiate into a more primitive form of trypanosome. They change their coat, so to speak. They have a coat on the outside that's laid down as an antigenic signal to the host, at least in this case. But for the fly, it's not an antigenic signal at all. It just represents the stage of the infection that begins the journey back to the infectious stage for another animal. And that takes about a week and a half to 2 weeks to develop.
So they go from the gut to the salivary gland.
They do.
And in people, obviously, there's migration as well, right?
Well,
you get in the blood and that's it?
It's in the blood and that's it. These are blood parasites only.
So they're being flung through the blood by the forces of pressure in the
They also get into the
CSF would be probably the critical.
The cerebrospinal fluid. They do get into the cerebrospinal fluid.
How do they get in there, by the way? Do we know?
They penetrate directly through cells.
Through the endothelial cells?
They're very capable of doing that. Yeah, but they're not intracellular parasites, though. Remember, they live in fluids only.
Yes.
Which is the important distinction between your African trypanosomes and your American trypanosomes, which actually are intracellular.
Yeah, obligate so.
And these are lovely, undulating,
they're fantastic organisms.
Right?
They have lots of nuance, as they would say. And biology. They're loaded with biology.
All right. The other aspect of this work we have to talk about a little bit is the mRNAs of these organisms, these trypanosomes. They're all, of course, mRNAs are what encode protein, right? They're all trans-spliced.
Isn't that interesting?
They all have a leader stuck on the 5' end by trans-splicing from a donor. It's called SL, spliced leader, SL. We're going to have to remember these abbreviations,
there's
aren't
a ton of abbreviations.
That's one of the challenges, right, of this paper is they throw a lot of interesting, complex verbiage out, and then you have these abbreviations which you've got to remember going all the way forward.
Yeah, that's true.
But we'll help our listeners.
This SL has got a cap on it. It's a cap structure. Why are you frowning? Don't you know what a cap is, dude?
You're going to tell us.
The cap is a modification of the 5' end of messenger RNAs that's required for efficient translation.
Okay.
And it is typically a G residue attached by a 5' to 5' linkage to the rest of the mRNA. Usually the bases are 5', 3', 5', 3'. This is weird. It's 5', called a cap. Do you know who discovered this cap? By the way, it was discovered in a virus, reovirus. Aaron Shatkin
would have never guessed.
Used to be at Roche Institute for Molecular Biology.
Okay.
And for many years, he was my neighbor. I used to see him running by on Saturday mornings, jogging. And I said to my son once, that is the man who discovered the cap structure on mRNAs. And my son used to tell people, can you believe my daddy tells me this?
Yes.
Why not? He's running right across the street.
He didn't sing with Bruce Springsteen.
But this is interesting stuff, right? I mean, I don't think a lot of people realize as I say that, I think how many of us, we sit around and think about like mRNAs.
Yeah.
But there's a normal concept, I think, when biology is taught. You've got your big, long strip of DNA, and then you make a copy that's RNA, and then you chop out some introns and you're left. But this is an interesting issue. You've got your RNA, but it's missing this. So it's got to get this cap from another part of the DNA and get put on so that it can go into the machinery and protein and everything else can be made.
Yeah. So this cap on the trypanosome mRNAs is unusual too because it has extra modifications. So normally mammalian caps have methylation on the first base, that G, and then the first few bases of the mRNA, and they're all on nitrogens. There's a methyl put onto the nitrogens. This structure, it's called Cap4. In addition to that, it has methylations on the ribose, the sugar moiety of each base. Like the first 4 or 5 bases also have a methyl.
So does this speak to the difference between protozoan and mammalian ribosomal machinery?
It might.
as to how it interacts with the
It
mechanism of protein synthesis.
Yeah, because, the way that the function of the cap, there are cap binding proteins in cells that bind the cap, and they in turn recruit the ribosome. That's how the ribosome is brought to the mRNA via these protein cap interactions. Okay. So these modifications may certainly influence that. If you take the methyls off, the cap binding proteins don't bind as well.
There you go.
Anyway, so that's SLRNA, and SLRNA is going to play some role in this paper.
Indeed.
Because it turns out that if you silence the production of certain proteins in the cell, they're called SM or SMN or geminin 2 factors, the biogenesis of this SL is blocked. The RNA accumulates in the nucleus, it goes into the cytoplasm, and it forms cytoplasmic granules. So in other words, when you block the biogenesis, something weird happens. Because you're no longer splicing it to mRNA, so there's excess SL. So it goes out into the cytoplasm. Normally it's in the nucleus. It's going to be stuck on mRNAs. It goes out in the cytoplasm. And so they're looking at whether this has some function. And the function they're looking at is involving exosomes. Now tell me, Dickson, before this paper, had you heard of exosomes? No?
I might have heard it mentioned somewhere, but I never really understood.
And Daniel, had you heard of exosomes?
So my first exposure to exosomes and the concept of exosomes was some work on CLL. Yeah. And it's interesting. A lot of science
chronic lymphocytic leukemia.
Exactly. And it was a flow cytometry issue. So a lot of times when we're studying something, so by flow cytometry, we will say, we want to look at stuff that is of a certain size because things below that, it's just debris.
Right.
Smaller than cells.
This is debris.
And so it's an interesting historical thing because people would look at these, years back. Oh, that's debris. Let's gate that out. Let's not look at that. And so some people doing CLL work said, let's look at the debris.
Yes.
And you start realizing that there are these subcellular things, we'll call them things, just to be very general. And when you start analyzing them, sometimes they've got proteins on the surface. Sometimes they have genetic material inside them.
That's right.
These subcellular things actually have the ability to bind to other cells and basically share genes, share different things. And so, this is interesting to carry along that work. The stuff that we said, just stop looking at that. You know what? The grad student probably scolded. You're not drawing your gates correctly.
We have the same thing when we used to run gels in the old days. Let's say RNA gels, right? There was always some schmutz at the bottom. We cut it off and threw it out. It was really small. Well, guess what? All the small RNAs that are so important were down there. We didn't even look, so we wouldn't have known.
Throw that out.
Throw it out. Cut it off. It's schmutz.
That's right.
Throw it out. So exosomes are small vesicles that are formed within cells, and then they are shoved out of the cell when they fuse with the plasma membrane. So they're formed within a multivesicular body inside the cell, and then these bodies go to the surface and fuse, and they put them out there. And this whole process involves a system called the endosomal sorting complex required for transport. It's called ESCORT, ESCRT. All right, and these are incredibly interesting little vesicles. They have, as Daniel said, they can have nucleic acid in them. They can have protein in them. They can have small molecules. They can have proteins on their surface, and they're so important.
It depends on what the cell wants to say to the next cell, right?
Depends on what the cell wants to say, whether it wants to help it or to inhibit it,
there
right?
You go.
For example, in the placenta, it's been shown that placental trophoblasts produce exosomes that have microRNAs in them that fuse to neighboring cells, and they inhibit virus infection. Can you imagine? And this is just one example. And they've been shown to be in Leishmania and trypanosomes previously. So they want to make a connection. In this paper, they make a connection between these slRNAs and exosomes, and they say it's involved in migration. Social motility. Here we go. SOMO. We have a neighborhood here. We have several neighborhoods called Soho, south of Houston.
Yes, that's right.
We have NoHo, north of Houston. Do you know of any others? There are others, probably. In Washington, there's one.
Dumbo. No. Yeah, there's Dumbo.
What's Dumbo? What's Dumbo?
Dumbo is in...
down under the Manhattan Bridge.
Really?
Yeah, isn't that funny?
We have Tribeca.
What does Tribeca stand for?
Triangle between Broadway and Canal.
Yeah.
Anyway,
Racaka.
I like Soho. That was the original one, Soho, right? Anyway, here in Trypanosomes, we have SOMO, social motility.
I will wrestle with that concept.
It is when
Sumo wrestling?
when two cohorts, PCF, what is that again? Procyclic factor. What is it's the one of the factor. PCF. I'm missing the.
This is the stage.
Procyclic form in the midgut. So they call it PCF. So,
that's not its name, but they've named it that, and that threw me completely off. When I started to look for the term again, I couldn't find it.
when two cohorts of PCFs come nearby, they change their direction so they don't contact each other. So they must be communicating, right? They must be putting out a small chemical that does that, and they want to know.
Maybe they're just both negatively charged.
Charged? You think that would be enough to repel these things?
Well, that happens. That's
all right. So
particles.
This is a very long, complex protein, but we're going to distill it for you so you understand it because we don't want to go through every experiment.
So we're looking at cellular language now, aren't we?
Cellular language? I thought that was DNA, dude.
No. Those are the interleukins and all the other messages that are sent out. Cells have ways of communicating with each other.
Interleukins are just sent out on their own.
Yeah, but
these are messages sent out in exosomes or small vesicles of some kind.
Yeah.
Okay, they're not sent out naked into the world like humans are.
Of course not. Well, look where these things live. They live in the blood supply.
Do you know why humans are so helpless when they're born?
Tell us.
And animals are born ready to go?
Well, we can swim when we can walk and swim when we're born.
Just so they can be born. Otherwise, the head would be too big and they couldn't be born.
Well.
So we evolved to be small at birth, and we have to last a long time.
So maybe the analogy is the cytokines and the chemokines are like telegrams.
Right.
And these are packages.
This is snail mail.
Yeah,
FedEx.
You bring it inside your house, you shut the door, you open it up. There's all kinds of good stuff in there.
When you see packages on your step, do you get excited when you drive home?
No, I listen to tick.
No, at this point, I'm like,
too many, right?
Too many packages.
I don't.
Only if it's a Blue Apron box.
Blue Apron, then you get excited.
Exactly.
Yeah.
I'm waiting for the drones.
When you drive down the street in the suburbs, every house has boxes.
Yeah.
On the front. It must be a gold mine for people to just come and get them. The delivery people drop them off, and the next people come and take them.
In Mountain View, California, they now have autonomous delivery systems on wheels that actually go between the sidewalks and deliver things into the stores.
Without people?
Yeah, no people.
Oh, that's great.
It's kind of like watching R2-D2.
Maybe.
So they start out by asking what proteins bind these SLRNAs. Do we remember what SLRNAs? Splice leader RNAs, right? So they make a affinity column, and they basically purify a variety of proteins that bind to these. They identify them by mass spectrometry, all right? And one of them that they have a variety of functions, but one of them that they look at for the rest of the paper is a protein which you're going to recognize this name right away, ZC3H41.
Oh, yeah. Yeah, we used to play with that as kids.
They've chosen it because it had some features that suggested it might be involved in RNA metabolism. So they use it as a marker for granules, packets inside the cell that contain SLRNA.
Good idea.
Okay? And they show that this protein will bind, this protein can be silenced, so they silenced it with siRNA, and it's essential for growth of the trypanosomes, which, Dickson, I presume you can grow in medium, right?
You can, yes.
So if you silence ZC, we have to have, how about ZC? Can we call it ZC?
ZC is fine.
If you silence ZC, the organisms die. Okay, so that's needed for something important. And this is a protein that binds the SLRNA. All right, that's what you need to know. Now they do another experiment, which was interesting. They silence not only ZC, but another protein, SME, which is important for the generation of SLRNA. And when they do that, they get a considerable reduction in the level of the protein and in the level of SLRNA. So they think that ZC is essential for accumulation of SLRNAs. Now, these proteins, by the way, are in the cytoplasm of the cell. And if you silence SL production by silencing SME, and this is complicated, they form granules. Okay.
Right.
Now, basically, when you prevent SL from being spliced onto messages, they start to accumulate in excess. They go out into the cytoplasm. They bind a variety of proteins and they make granules. A granule is nothing more than a collection of proteins in the cytoplasm. Okay, and there's a whole lot of different kinds of granules in the cytoplasm. There's stress granules, there are RNA granules, there are Peabody, okay, and they're all distinct.
So should we talk about what those are? Maybe that would help.
Sure.
People are not.
So these are things that arise in the cell when you stress cells. All right, it's a way of the cell of putting things in places when there's a stress condition and it wants to hide them. So, for example, when you stress a cell, one of the things that happens is that all the mRNAs that are being translated, they get shunted into stress granules, and they're shut off. They're no longer translated because the cell is like, wait a minute, things are not good in the outside world. No point in making proteins right now.
And you get heat shock genes turned on also.
Heat shock genes then get turned on to try and fix whatever is going on.
Certain things in cells.
Yes.
And I think of stress granules as sort of a safe storage site for our,
Fair enough.
our mRNA. Let's keep them here, safely store, wait till whatever's going on passes.
That's right.
And then P-bodies.
P-bodies are processing bodies. This is similar function as stress granules, except they have different components, right?
I think of them almost like a ubiquination process. There a lot of processing degradation of RNA occurs in those.
Processing bodies, that's what the name stands for. Often a lot of things that get shunted into stress or P-bodies will get degraded if good conditions don't return, right?
Exactly.
If whatever's causing the stress persists, then they're going to degrade all this stuff. And they show essentially for the next series of experiments that the granules that this slRNA go into are distinct from P-bodies and stress granules. They can look at silencing. They can look at markers.
And I think that's important because otherwise people said, oh, you just discovered.
Yeah, of course.
You're looking at P-bodies. You're looking at stress. And this is a special new granule.
Something
That's
else.
Right. All right. So it's a lot of
entirely new.
Very nice experiments that we don't need to talk about. All right. But that's the conclusion. Now, what happens to this slRNA that's in the cytoplasm? They want to know next. We know that if you inhibit SL splicing, it goes from the nucleus to the cytoplasm. It accumulates in special granules. We'll call them SL granules if you'd like. So they said, do they secrete these RNAs in exosomes? So they do microscopy, and they see exosomes, 100 nanometer exosomes, and they can purify these and show that slRNA is in them. You with me, Dickson? You can easily purify exosomes because they're little membrane vesicles, and you can purify them on gradients and so forth. They can tell that there's RNA in them. And guess what else is in these SL-containing exosomes? ZC.
Good old ZC.
That protein that they identified originally as binding slRNA. It's in, They say here, this is funny, ZC was found to be massively secreted via exosomes. Massively. I love the word. All right. So the exosomes, here again, you're inhibiting splicing. The slRNA goes into special granules, and then it gets shunted out of the cell by exosomes along with this binding protein. Why would the cell want to get rid of it? Well, we'll see if we can learn something about that. All right. So then they say, what is the cellular pathway that leads to the production of these SL-containing exosomes? Okay, so they can knock down components of the escort pathway, and they can look to see if these exosomes are being produced. And they find that these are produced by the escort pathway from multivesicular bodies. All right, and this is a known pathway that is producing other exosomes as well. You know, one of the other things that's interesting here is that it was previously shown that some of these exosomes are produced by budding from the flagella.
That's right.
It's weird, isn't it?
Very weird, except if you look at the organism's ability to take up nutrients or to secrete things, its entire body is coated with this single protein, which is called a variant surface antigen, except in the flagellar pocket. And that's where all the active transport takes place for this organism to import its nucleic acids and amino acids and things of this sort, and it exports through that same port. It's the only It's the only portal to the outside or inside of the organism. The rest is all covered with a Gardol shield or something like Teflon, which prevents anything from coming in and out, and that's why it's so effective in terms of resisting immune attack.
So we've actually talked about trying to target that. That's like a vulnerability point.
Right. They show that in fact these vesicles that bud from near the flagella also contain this SLRNA.
Yep.
It's a different pathway. It's not their production is not mediated by the escort pathway, as are the other.
It almost looks like a bleb that just sort of buds off from the membrane surrounding the flagellum and becomes a vesicle.
Okay, so far we have exosomes that are produced and they contain SLRNA and proteins that bind SLRNA.
And massively produce
it
on these hot, as they suggest, during hot summer days. So now when it's really hot this coming August, I'm going to be thinking about massive exosome shedding.
That's the next experiment, in fact.
It's more than 9,000.
So far, the production of these exosomes has been stimulated by inhibiting splicing, by knocking down this SM gene that's needed for splicing, right? And now they say that's kind of an artificial
Exactly.
thing. Let's study something more natural. So they say, let's try heat shock.
Yeah.
Heat shock has effect. And in fact, when they heat shock cells, it inhibits cell splicing, and the SL is exported to the cytoplasm. It goes to granules, and then out it goes in exosomes out of the cell. And again, they say massive secretion of exosomes in heat shock cells. And they say, well, when would this ever happen? Well, Dickson, you have to tell me what you think. Exosome secretion takes place during heat shock and may occur when the fly host is exposed to high temperatures in the summer. Does that make sense? Don't they just live in hot temperatures all the summer?
Yeah, but it can get very hot sometimes, over 45 degrees centigrade.
Over 9,000.
Over 9,000, that's right. I mean, they live...
Maybe it's when the tsetse flies want to feed, it's really hot.
The East African tsetse flies live in an open area, whereas the ones that in the western portion of Africa live near rivers. But these are very, very stressed out during some parts of the dry seasons, I'm sure. So here's a survival mechanism for its parasites.
So here we go. Heat shock, SLRNA is then produced, and it leaves the cell via exosomes.
Yep.
They then do a lovely experiment where they label these exosomes, they purify them, they label them with a lipophilic dye.
Yeah.
And then they add them to fresh brucei cells.
That's right.
And show that the dye gets into those cells. So obviously the exosomes are being taken up.
Correct. They receive the message.
They're receiving the message.
That's
of course,
right.
This is an artificial experiment where they're just adding them, but the extension would be that in nature, if a trypanosome is producing exosomes, maybe neighbors are picking it up.
Exactly.
So then they say, what might this function be? So this is where they look at social motility.
Social motility.
The only known cell-to-cell communication between trypanosomes, SOMO, or Soho. They don't go to Soho. They show SOMO in Soho.
It's south of Missouri.
I thought of that, too. And so they ask, they have this lovely assay where they put them on agar semi-solid media.
Yeah.
And they can show that wild type will get only so close. They form clusters on the agar.
Exactly.
They only get so close.
Right.
And they must have some way of sensing when another colony or another clump of cells is nearby. And so they say, could it be involving exosomes? And so they actually make mutants by knocking down genes that aren't going to make exosomes, and they show that wild type cells will get closer to them than they would to another wild type cell if you knock out the exosome production of this small RNA. There are other factors that are controlling this repulsion, as they say, repulsion between two parasite communities, but the exosome pathway is one of them. They say it's got a repelling activity. So these exosomes with what is it again? S-cell, short leader RNAs.
Spliced leader
RNAs, thank you.
You're welcome.
Are involved.
I kept switching to short for some reason.
No.
They should call it SBL.
I don't know enough to switch.
Spliced leader.
Okay, so exosomes coming out of cells are responsible for repulsion between two wild type colonies.
Yeah, so normally they would come to, like, they say 0.59 centimeters, pretty close.
Right.
But if these things are being massively expelled, then they're going to keep like a centimeter on average distance. So almost twice as much distance to they're getting the message. That's the don't come hither look.
Exactly.
And they have to be intact exosomes. When they disrupt them with detergent, it doesn't work. They can actually put exosomes, purified exosomes on these cultures, and they will move or right next to them on the agar, and they move away from it. So whatever is in the exosome is telling them stay away. But if they break them open with detergent, it doesn't work anymore. So there's some signal there. And they also do some time-lapse microscopy to show these things, how they move towards each other or move away. It's quite interesting. There's a massive amount of data in this paper.
There's tremendous numbers.
I was impressed. I mean,
me too.
People often give a talk and they talk about, we published this, we published this. This is an entire talk.
Exactly.
Totally.
I mean, this is a lot of data.
Like a thesis, at least, or more. And so exosomes secreted from cells transmit a repulsive signal. That is the concept. That's the conclusion of this. And there are a few more experiments where they mix wild type and cells excreting exosomes, and they show that they make different kinds of clusters. But the bottom line is that these sLRNAs are excreted in exosomes, and migrating parasites avoid contact with them. So maybe, so here's the story. When these cells are excreting the exosomes, it's because there's something wrong in those cells. And so the other cells want to avoid that. Mm-hmm. Now, why would they want to avoid? They're not going to mate, are they?
No.
So
although
maybe they would hurt them in some way?
Although they have found sex cells, sex differences between trypanosomes. So there is a sexual stage to it.
But maybe just having a bad trypanosome around could injure the whole community, so they want to stay away from it. So we're humanizing a little bit.
We're
here.
Anthropomorphizing like crazy.
But what we do know is that these are repulsive. And so the next step is to figure out what's the mechanism of repulsion, and more importantly, why.
Remember, these are insect stages.
These are insect stages that they're studying here.
That's right.
Correct.
That's right.
So we're talking about things that happen in the insect.
Right.
So
migration in the gut tract of the infected tsetse fly might be one way of signaling, okay, I'm at my stage of differentiation now, and to let you know that, I will just throw out some exosomes and let you know that, hey, by the way, you guys should be moving down towards the salivary glands.
The thing is, if it gets hot out, the whole fly is going to get hot, and so all the trips in the fly are going to be hot. So,
yeah, but these are not stupid flies. These flies will seek out a cool environment. I'm sure of it. But you're right. I mean, I think that the moment they fly out into the sunlight, the temperature is going to go way up.
They mention some interesting results with Leishmania, which also secrete exosomes in the lumen of the sandfly midgut.
That's right.
In fact, they say that when the insect bites, these exosomes come in with the bite, and they affect the host by inducing inflammation, and it exacerbates the lesions, right?
We talked about that just yesterday, indeed. Leishmania has the ability to infect cells that ordinarily would protect.
Yeah.
And by inducing an inflammation, this is like bringing in more host cells for the parasite. So that's very interesting.
So they say these exosomes should be considered Leishmania virulence factors. It's interesting, isn't it?
Well, it depends on how many language molecules you want to talk about here, because how many different things can you put inside of an exosome? And then when you receive that message, what do you do with it?
That's right. So basically, exosomes are markers of well-being of the parasite. That's what they say. And if they are sensed, if other parasites sense a parasite that is not well, they will shun it. They are not altruistic, Dickson.
No.
They don't want to help others.
There are no physician Leishmania or trypanosomes.
If Daniel senses an ill person, he will help them. But if a trypanosome senses an ill trypanosome, it will shun them.
Yeah.
We're so lucky we're humans, aren't we?
I think.
What do you think of that, Daniel? Is that cool?
I'm trying to figure out if maybe make this more of a mechanistic thing. Is because so you're in there in the insect, and you're in a certain position where this replication is
like occurring. In the gut, say, right?
And you're in the gut, but they need to get from the gut to the human being, right? So they can't stay in the gut.
They have to go to the salivary gland, right?
So,
That's true.
So I was thinking,
at least.
so I was thinking of this analogy. So here it is, a hot summer day, right? When we've got this massive excretion, and the tsetse fly, is now hot and thirsty, and it's going to go get a nice drink of blood. Except that's not exactly the way the transmission occurs, right?
No.
Is there somehow that when the tsetse fly would be feeding, you want to somehow get the timing right? Because the only time you want to really be in the salivary gland location is when the tsetse fly is going to be feeding. So these are not nighttime feeders. They're not fighting. You want to somehow have a trigger that when it gets hot during the day, when the tsetse fly is going to feed. So that's what I'm thinking. Like they sort of put it as, the survival, let's get away from the guys who are in trouble. Where are you going to go? Right? I mean, there's no getting away.
That's right.
So do you want to get away?
Sure.
Because now you want to get into that mammalian host. So it's hot. Tsetse fly is going to feed. You've gone to the salivary glands. He does that horrible cutting with the tsetse flies have these horrible blades and they cut you. And then the tsetse flies can enter the wound. Right. I mean, not the tsetse flies, the parasites can enter the wound.
Yeah.
So that's what I'm thinking is maybe this is a timing, not a let's get away from noxious stimuli.
Maybe.
So one other thing to ask then for this experiment is that do all these rearrangements of the exosomes with regards to what they contain through these knockouts, etc., how does that affect the infectivity of the trypanosomes inside the tsetse fly? You can actually do that experiment because this will infect mice. So you can see whether or not any of this has any effect whatsoever on transmission.
I'll bet they're doing that.
I hope so, because this is very complicated but very well done.
By the way,
very visual paper.
I didn't say this. The first two authors are co-first authors. Dror Elias and Sriram Kannan are both co-first authors. And to indicate that, Plas puts a little yin-yang symbol.
I see that.
Next to the first. Isn't that cute?
I did see that.
I like that very much. And I saw it, and that made me realize that they are co-first authors. All right. Cool paper. We do have some email, gentlemen.
We do.
The first is from Elise, who writes, Dear TWiP Trifecta, I am not even close to being caught up on TWiP episodes, but I did listen to TWiP 127 and was quite abashed to hear my name mentioned for being truant. I did indeed fall way behind on my listening and researching and writing. I can't offer any excuses beyond the obvious life gets in the way, one that just feels rather shabby. I'm now in the process of getting my act together, and I promise to write again with diagnoses pronto. Excuses aside, I have missed very much this parasitic detective work, even though I am prone to diagnostic stumbles. More soon, very soon. Best wishes to all. Elise in Lower Manhattan. Would that be Loma?
Loma. I like that. Loma.
Now, Elise, we just missed you. We just missed you because you were here so often. We do not let us make you feel guilty in any way.
No. If it motivates her to write in, please assuage your guilt.
Dickson.
I thought you'd ask me this. Wait, I'm busy booting it back up again. It's just
here, Steve writes. Do you want to read from my... you're going to catch up?
There. I'm
Daniel,
technologically getting there.
You have an iPad today. You usually have a laptop.
Can you believe I forgot it? I have to get up really early on Tuesday. So
I'm sorry.
I don't know. I
Can
got
you
like
see that?
5:30. I'm young and still have
you're still young.
vision intact.
So Steve writes, Hi, Vincent et al. Just come across this piece on gruesome-sounding brainworm. Whether or not the unfortunate moose, executed for blocking a snowmobile trail, actually was infected remains to be seen, but this would appear to be another example of a parasite that causes little harm in one species, affecting behavioral changes in another. Might make an interesting topic for TWiP, maybe even a case history to stump the chumps. The life cycle of P. tenuis is complex and multi-staged, he quotes. Adults will lay eggs on the dura mater, the outer layer of the meninges of the brain, or directly into the bloodstream of an infected host. The eggs hatch into first-stage larvae, which travel in the bloodstream to the lungs.
I'm
sorry.
Lungs. I'm going to give you a pronunciation guy.
No. The tail of the G was cut off.
These are what you breathe with, Dickson.
Thank you. Now you tell me. To the lungs, where they travel up the respiratory tract, are swallowed, and then pass out of the body in the mucus coating of the fecal pellets. Gastropods fed on this mucus and ingest the larvae, where they develop into a second and third stage. Infected gastropods may then be accidentally ingested by a herbivore, and the larvae move from the gastrointestinal tract to the bloodstream, reaching the central nervous system, where they developed to adults, and the cycle begins over again. An end quote. Amazing. We have any wild animals left at all, really. All the best, Steve, from Bedfordshire, England.
This is a ProMed Mail report of Michigan. A Michigan officer killed an elk suspected of having a rare case of brainworm after
an elk or a moose?
It blocked an elk. It blocked a popular snowmobile trail in northern Michigan.
Huh.
Well, it says elk in the report.
Interesting. He says moose because that's very interesting, because I think that there are differences between Europe and the United States with regards to whether it's a moose or an elk.
Yeah, it could be.
They have no elk in Europe, so the moose is, I think, called an elk.
So the animal's head is being sent for testing.
You're right, Dickson. Actually,
by pathologists. So 500. So they're going to check to see, but there have been a handful of these cases in Michigan in elk in the last 5 years.
How about that?
2-inch worms as thin as a human hair. Wow.
As thin as a human hair.
And they infect
deer as well.
Yes.
Yeah.
Well, there are some brain parasites that we discuss also. Angiostrongylus, which is a brain parasite of rats, and sometimes accidentally in people.
Steve also sent a link to a video, which is a stop-motion cartoon of the life cycle of a schistosome, out posted for World Water Day in the UK.
Right.
World Water Day. Schistosomiasis is the Natural History Museum, NHM, of the UK, followed the circular life cycle of schistosoma, a life-threatening parasite that can live in water snails and even people. There you go.
People.
Even people.
Especially people.
There you go. And that's it.
Nice.
That's TWiP. Hey, it's 130. Number 130.
Right.
It's
Did we want to do another case, or we're gonna?
Oh, you're right. I forgot all about the case.
You've been marginalized.
Apparently,
we're supposed to do the case before the email.
No worries.
That's okay.
Daniel.
We have no particular order.
Maybe this will be like people will have the what happened. Maybe they were serious.
Daniel, do you have another case for us?
I do have another case.
Superb.
I'm glad he's on the ball and he remembered too. Otherwise, I would have wrapped up.
I did all this work.
That's right.
All right, here we are. We are back in Peru. This is a 24-year-old female that I saw in the emergency room while I was down there. So this 24-year-old female lives in a rural area outside of the big city, right? In an adobe house up in the highlands of northern Peru at about 3,000 meters. So what's that, like 10,000 feet? Translate that.
Pretty high
feet. So she lives high up, and she comes in because she's quite ill, and she has a skin lesion, and she's had this for 48 hours. She reports that 2 days before, she was pulling on her pajamas. You know, it's dark. She's pulling on her pajamas to go to sleep, and she felt a sharp, sudden pain in her right upper leg. The next day she found, I'm going to call it a small living creature in her pajamas when she was taking them off. The left lower, actually it's the right lower abdomen where she felt the pain initially. And she says abdomen, but it's really going to be right at the crease where the leg meets.
The inguinal region?
It's right. Yeah, it's actually right in the inguinal region.
All right. That's in southern Peru, as I recall.
Yes.
So it's the right inguinal region.
So it's really the right inguinal region. We'll
Okay.
sort of give people that. You know, she says it's her belly. You know, how good's my
bugs
Spanish?
like to go to the
how good's my
creases, right?
Spanish, right? Which comes up at times. You know, that's an aside. So she, where she felt this pain, she went on to develop. Initially, it was a red lesion. The red lesion enlarged, and then it developed a black central dot. Okay. Now she begins to feel really ill. She starts vomiting, and she's brought to the hospital. Actually, she comes with her brother, similar in age.
Okay.
So when, initially we were seeing her in the ER, right? So we're going to get a little bit more before we get stuff. So initially she's assessed, and she doesn't have a fever at this point. She's breathing a little bit fast at about 20, heart rate 70, blood pressure 160 over 10. So she's a little bit anxious and upset. When we examine her, I actually have a photo, but I'm going to have to cover it because, I'm a doctor, right? So I take pictures and I don't realize, oh my gosh, that's probably more exposed than I want Dickson to see because he's not a doctor.
I can handle it.
But Dickson, I'm going to show Dickson. We see in her right inguinal region, sort of an enlarging, almost necrotic area, I will say. Probably now a centimeter or two. And she's starting to look pretty sick. Her white count is up at 26,000.
Lord.
With a left shift, 72% segs.
Left shift.
Platelets are 200. Her eosinophils are 4%, right? So you can sort of do the math on that, which, it would be a slight eosinophilia, but it's marginal. It's not really... her bilirubin 3.5. Her creatinine is 4.9. Right, so she's
what
actually
was her bilirubin
3.5.
Was that a bilirubin or bilirubin?
And
That's her bilirubin. Her creatinine is 4.9. So she's going into renal failure.
Oof.
She's actually reporting that she's not making much urine. We put a catheter in, and there's very little dark concentrated urines. You'd say that's good at this point that she's still concentrating, right? Yeah. Her hematocrit, the normal hematocrit should be about 40, right? It's 14. So she's severely anemic. Her BUN is 59.7. Her CPK, which is like a muscle enzyme, is 227. That's elevated. There actually are RBCs and leukocytes in her UA, in her urinalysis. And so we've got this lesion. Prior to this, she says, past medical history, no health problems, no surgeries. This is like a first interaction with the health system, other than, like local people she went to for grippe and, respiratory things. Yeah. Nothing significant in her family history. Mm-hmm. There's animals around, but she doesn't have any personal pets, no toxic habits.
But she lives in an
adobe house up in the highlands.
So adobe means made of mud.
Actually, it's a high clay content mud
and clay.
Yeah, they'll often use straw.
That's right.
And the roof is made of the same.
It's a thatched roof.
Thatched roof.
As depicted in figure.
Yes, dirt floor.
We have a figure in our book that shows a typical house like that in
dirt
Bolivia.
Floor.
That's right.
Dirt floor.
Yes.
So it's adobe thatched roof, dirt floor.
And I presume no sign of the critter that she suspected.
So she actually, that's the great thing. That's one of the nice, that people are educated in certain parts of the world, in certain areas that maybe they wouldn't be educated in other areas. So she brings in the critter.
Nice.
So we actually get to see the critter.
All right.
So Dickson seems to think there's a critter involved.
Well, she said there was a critter. I'm just following up on this. So I have my suspicions immediately.
She called it a small living creature.
Yeah.
Yes. So So fortunate for us, she brings us the small living creature.
In a
so we actually get to
it's
in a container. So we actually get to examine the small living creature.
Cool.
Exactly.
How small was it?
We're going to talk about that next time. We're going to talk about how many eyes it has, how many legs it has,
okay,
what size it is, what color it is.
Right.
And so I will say that there are creatures like this in our book.
There are.
It'll be interesting. The question might come up. Is this really a parasite?
Exactly.
Was it a spider? You're not going to tell us, right?
I'm not going to tell you.
Okay.
I might tell you, Vincent. No, actually, I won't. I won't even tell you.
Especially because he's got so many podcasts. He'll probably blab it all over the air.
What are you talking about? I wouldn't blab it. Don't worry.
So it's an interesting case. This woman is really quite ill. And so what are we going to... So these are, I guess we'll go through. What do I want people to think about? So one is we've got the critter. That's going to be helpful. So we have a leg up? Is that the expression?
How many legs up?
We have something up.
6 or 8 legs up.
We have something up on people. But what are you thinking about? What could do something like this? That would be one. Two, based upon what you think it might be, how would you treat this young woman? What would be the approach to treatment?
Okay.
So those are the big.
Dickson, you have some ideas?
I have only one idea.
You know what it is already,
I
right?
think so.
What a guy. Amazing.
Well, no, come on. This is my livelihood. This is what I do for a living.
Used to.
I still do it.
Tell me how you do it. You write books?
I do.
You don't examine stools anymure, right? Maybe you should. Maybe you should.
No. He gave me a chair when I retired, not a stool.
Yes, I understand. Yeah, but some people
I think that this is...
would forget. Some people would forget.
I wouldn't forget.
Dickson, what if in 10 years we're doing this and you can't remember? All of a sudden you forget everything.
Well, then you can commit me to
the man who
local
forgot
institution.
The man who forgot his parasitism.
No,
These will be like the earliest memories will come back, like
I'll
your
tell you
native
something.
language parasitism.
no, this is that's a valid question. Because
He won't remember his wife, but he'll remember,
Stop.
that's Diphilobothriem latum, I can see.
That was his last words. No, really, I knew someone who knew they were developing Alzheimer's disease because she forgot how to cook.
Oh, gradually, I suppose, right?
No, it happened one afternoon, and she walked into the kitchen. She says, I don't remember anything about this recipe, and I used to do this from rote. And he says, well, just look it up. She says, that's not the point. The point is that I've never had that happen to me before. So I'm still not there yet. So let's not all worry about me out there, folks. I think I still know what this is.
Yeah.
Yeah.
I
And
can
we're
even
still
tell
doing,
you-
and we're still doing clinical cases. People were more worried about
and
that.
the genus and species. I think I can
That's right.
I can even tell you where this might have what might have happened after that.
Okay.
That's right.
Okay.
I could be wrong, however.
Is this in Parasitic Diseases 6th edition?
Yes, it is.
So people who are curious what this might be, go ahead.
Go to read every paragraph that...
I must say that I actually took that picture in that book too. I took the picture.
And there's actually,
if it's what I'm thinking of.
Yeah, and we just recently finished the revision of what will eventually be the second printing,
Right.
and we had the help.
new
We had the
additions.
help of a great group of entomologists at University of Nebraska,
Nice.
Amy Murillo and Jonathan Larson.
Nice.
Jonathan Larson is a fellow podcaster. He does Arthropod.
Yeah, we
And,
mentioned him on TWiP, I think.
Oh, has he come up?
Arthropod. He came up because I was talking about doing a bug podcast, and the person I wanted to do it with decided not to.
Oh.
And so a listener wrote in and said, hey, there's this Arthropod podcast about bugs. Yeah, so we mentioned that
Yeah, no, he was
podcast
very
on
kind.
TWiP.
Oh, just a few areas you need a little entomological polish, and then 5 pages of single-spaced
Good.
polished comments. So,
That's cool.
Yep. So our next printing will have an improved
Plus the
bug
pronouncer's
section.
gazetteer.
Yeah, plus a way to pronounce things properly.
When is that
I won't
coming
do the
out?
bugs. I'm not going to do the bugs.
When
Well,
is
so
when
the,
is the Gazetteer coming out?
As soon as you can put it up online.
Is it done?
It's finished.
Yeah, and the new edition is actually available as a paperback on Amazon. So people
So
feel
you,
like
you
they need
gave
to
me
jump
something to
ahead.
upload. Does it has the Gazetteer in it?
So I'll send that to you later today. But
I sent you a revised edition.
okay, so Vincent, you wait. And,
Okay.
And readers or listeners, I guess people
hang in
listening,
there.
hang in there, and then actually by the time this comes out, our latest bug improved version will be available for download
with
as
the
well
with
as
the production with the Gazetteer
with
for
the
production.
Gazetteer, so
Very
you'll know
good.
how to pronounce things.
All right. Parasiteswithoutborders.com.
Yes.
All right. That's TWiP 130. You can find it at iTunes. Microbe.tv/TWiP. Consider becoming a supporter of TWiP and all the Microbe TV family of science shows. Go to microbe.tv/contribute. We have a number of ways you can help us out, including Patreon and PayPal and Amazon affiliates, etc. So we can travel. I can take Dickson places and do podcasts, etc. We love getting your questions. We love getting your guesses for the case reports. Where do you send them, Dickson?
To microbe.tv/TWiP.
Well, I need an email address. You can't send anything at that way.
Oh, you'll have to tell them then.
You don't know? So if you were going to guess, you wouldn't know where to send it, would you?
Not off the top of my head. I
TWiP
wouldn't.
at microbe.tv.
See,
It's intuitive.
okay, fine.
Like, intuitive
All
as
right.
in it
I've
makes
never
sense.
sent an email to you before like that.
Yeah, I know. TWiP at microbe.tv. Dickson Despommier.
Yeah.
What websites can people find you at?
Well, I have trichonella.org.
Mm-hmm.
I have medicalecology.org. I have thelivingriver.org.
Right. And
I have Parasites Without Borders that I co-share.
.com. Thank you,
.com.
Thank you, Dickson.
You're very welcome, Vincent.
Daniel Griffin is at Columbia University Medical Center, which has a different name. I can't remember it. So parasiteswithoutborders.com. Thank you, Daniel.
Yes, and actually, if people go to Parasites Without Borders, there's a contact us link, so people could always contact us
they
there.
can get us there.
Yeah, there's an email, right?
There is.
There is.
For every one
We
of you.
welcome emails.
And
At,
that email link goes to the 3 directors, so we all get the emails.
Exactly.
I'm looking at the website for the medical center, and they haven't changed the name yet.
No.
Isn't it Irving?
Irving Columbia University Medical Center, something like that.
It's a husband and wife who gave up.
Oh, that's right. I don't remember. Anyway, thank you, Daniel.
Sure.
I'm
Always a pleasure.
I'm Vincent Racaniello. You can find me at virology.ws. The music you hear on TWiP is composed and performed by Ronald Jenkins. You can find his work at ronaldjenkins.com. I'd like to thank the sponsor of this episode of TWiP, Blue Apron. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
is
parasitic.